Let's jump right into this explainer. If you've been building with large language models, you probably have this one deeply ingrained assumption. Claude is an amazing code writer. You give it a prompt, it spits out a script, and boom, its job is done, right? But what if we just completely flip that assumption on its head? Today, we're unpacking a massive leap in capability detailed in the Claude master documentation. We are talking about the code execution tool.
Look, we all know the pain point here. You ask an AI to write a Python script. It gives you text. You copy that text, paste it into your local IDE, realize you have to install missing packages, run it, hit an inevitable error, copy the stack trace, paste it back into the AI and ask for a fix. It's just this incredibly tedious manual loop of copy, paste, crash, repeat. But what if Claude didn't just write that code, but actually ran it for you? What if we literally just eliminated that entire copy-paste cycle?
So let's look at section 1, inside the sandbox, running code directly in the API.
Okay, this breakdown brilliantly illustrates exactly how the paradigm is shifting. Think about a standard API call. Claude simply returns Python as raw text. But with the code execution tool enabled, Claude writes the code, spins up an Anthropic-managed sandboxed environment totally automatically, runs the code, and then returns the actual printed output to you in a structured block. It can run bash commands, install packages with pip or npm, read files, the whole shebang. And here is the absolute game changer. It uses a persistent container. When you make that first execution request, the API hands you back a container ID. If you pass that ID back in your next API call, the container stays alive. So files you created in turn 1, they're still sitting right there in turn 3. The state actually accumulates.
Moving on to Section 2, Automated Data Analysis, the Sales CSV scenario.
Let's make this concrete. Imagine your data team needs to process a massive CSV of sales records to grab per-region revenue totals, and you want the whole thing fully automated. Here is the exact workflow. Step 1, you upload the CSV using the Files API. Step 2, you send a prompt asking Claude to read that CSV with pandas, group the regions, and sum the revenue. Claude writes the Python, executes it right there in the sandbox, and immediately hands you back the formatted table. Step 3, because Claude also wrote those results to a text file called summary.txt inside the container, you can retrieve that exact file in any follow-up request just by using your container ID. There are literally no manual steps, no re-uploading the massive original dataset. It's completely 100% seamless.
Which brings us to Section 3, the efficiency leap, programmatic tool calling.
The crucial point here really comes down to a single number, 1. In a traditional agentic workflow, if you gave Claude, say, 10 external tools to use, it would have to call a tool, send the result back to you, wait for your API to return it, and repeat. That is 11 round trips between your server and Anthropic. 11. But when Anthropic tested this multi-tool pipeline inside the code execution sandbox, those round trips plummeted from 11 all the way down to just 1. Why? Well, because Claude wrote a single orchestration script, ran it inside the sandbox to call all the external tools itself, and simply handed you back the final aggregated result. The latency and token savings here are absolutely staggering.
Now for Section 4, Guardrails and Pitfalls, Security and Cost Constraints.
We have to talk about the pragmatic realities here, because this tool is not a replacement for your core compute infrastructure. First up, cost. Every single container session is billed for a minimum of 5 minutes of compute time. Yes, even if your task finishes in 2 seconds. And heads up, attaching a file via the Files API starts that billing clock immediately before Claude even runs a single line of code. But the absolutely critical warning here is security. If your sandbox has network access enabled and you feed it an untrusted user document containing a hidden prompt injection, things can go south fast. In Anthropic's own testing, a hidden instruction successfully convinced Claude to read a sensitive file and post it to an external server 24 out of 25 times. The lesson here? Always disable network access if your workflow doesn't explicitly need it, and never mix untrusted user content with sensitive credentials.
And this quote perfectly distills our key takeaway for this explainer. The code execution tool moves Claude from a code author to a code runner. When you pair this execution sandbox with the Files API and persistent container IDs, you are unlocking stateful, multi-step agentic pipelines that compute real outputs your application can consume instantly. It's a massive shift.
Now, if you want to start building with this right now, keep in mind this is an API-only feature and it's currently in beta. You absolutely must pass this exact header, Anthropic beta 2025-0825, on every single API request to actually unlock the sandbox.
To explore 3 fully worked examples, advanced implementation strategies, and really dive deeper into the code orchestration we discussed today, definitely check out the full chapter at cloudmaster.net. So, as you design your next AI pipeline, ask yourself, are you still forcing your application to act as the middleman for your AI's code, or are you finally ready to let the model run the show?